Today's objective is adding and subtracting fractions with unlike denominators. I would like you to think of fractions like arcade games, okay? You need the right coins, usually quarters, to play them. If you have a $5 bill, you can't go play them. Or if you have dimes or nickels, you need to change them to all quarters in order to play. So fractions are like that. You need to get it all with the same denominator before you can play with them, okay? Except we don't really think of them as playing. And this is only when you're adding or subtracting. Multiplying and dividing are a lot nicer, and we've done those, okay? It's not hard. It's just a little bit annoying. It's like when you have to go wait in line to get your money for the right, quarters, all right? This is a method that may be different, but it's easy to learn. And I tell you on the next slide, if you're good at doing it already, then you don't need to try this. Well, you could try this way, but you don't need to change. But otherwise, try it, because maybe it'll be easier for you. All right, number one, multiply the denominators. So we're going to go straight across. Number two, multiply to get the new numerators. First, you go to the left, and then you go to the right. Add your numerators and simplify. Reduce if necessary. So here's our problem. 2/3 plus 4/5. So I rewrote it, and I'll show you what I did. I said multiply the denominators. That's my blue arrow. 3 times 5 is 15. Then, since you stopped on the 5, it's an easy way to remember. Now we go to the left. 5 times 2 is 10. And then multiply the other way. 3 times 4 is 12. Notice I didn't rewrite it with two new denominators. I'm just saying I know my denominator is going to be 15ths. I'm also not using the lowest common denominator. I'll reduce it at the end if I need to, okay? Now you just add the numerators. 10 plus 12 is 22. And that's my answer, 22 over 15. There's nothing that's in common. If I wanted to, I could change it to be a mixed number, but since they didn't start as mixed numbers, I don't need to. But if I did, I would say 15 goes into 22 one time with 7 left over, and it's still the denominator 15. Okay? So, like I said, this way is a little different than how you learned in elementary school. If you're good at it already, don't worry. Don't change your way. But if it's still hard, try this way, because it might be easier for you. All right, here's our problem. 4/7 plus 1/3. So we're going to multiply the denominators. 7 times 3, I don't know why I said 4. 7 times 3 is 21. Then, since you just ended with the 3, now multiply diagonally. 3 times 4 is 12, and then you need to do the other one as well. 7 times 1 is 7. So I did the two steps that we're doing first in the blue and the other one in the red, just so you can kind of see. Now we add the numerators. 12 plus 7 is 19. 19 over 21, I can't reduce it. I'm good. All right? Now let's try one with subtracting. Same thing, we're going to multiply the denominator. 2 times 5 is 10. Notice how I set up the problem? I said equals line and then whatever sign is in the middle on top. Okay, you can do that, and then another equals. So 2 times 5 is 10. Now 5 times 1 is 5. And then let's change colors. 2 times 2 is 4. And this is subtraction. 5 minus 4 is 1/10. And we haven't had to simplify anything, so that's been kind of nice. Now let's look at another type of problem, one with mixed numbers. In the past, you may have been taught to change everything to an improper fraction first, and I am not asking you to do that, because when I go to play the arcade games, or let's not even think of that because I don't play arcade games. When I go to the store and I'm going to buy something that costs 75 cents, I don't take my $20 bill and ask them to change it to all quarters first. I can buy things with a dollar bill and change it. And that's what I want you to do. I want you to keep your whole numbers as whole numbers and just get a common denominator for the fraction part. So you need to remember that 2 and 1/5 can be written as 2 plus 1/5. And 3 and 3/8, that's the same as 3 plus 3/8. Now using the commutative property of addition, where we change the order around, I'm going to group my whole numbers together. 2 plus 3 plus 1/5 and 3/8. Okay? If I wanted to, I could even put parentheses around it so you can see what I'm doing. And that would tell us the associative property, huh? But I'm not going to, you don't need to do that. 2 plus 3 is 5. Oh no, it's not the same denominator. So what do? All right, I set up my problem. I brought down the plus. This is adding in between here, so that's why it's a plus there. So let's multiply. 5 times 8 is 40. 8 times 1 is 8. Going the other way, 5 times 3 is 15. And now I'm going to add my numerators together. But the reason I wrote the 5 in red is sometimes when you're doing this, you guys are so concentrating on the fractions, you forget about the whole number. Don't forget your whole number, okay? So 8 plus 15 is 23 40ths. And I can't reduce that. I can't simplify 23 and 40. They don't have any common factors. So I'm finished. Let's do another problem that's subtraction, okay? 6 2/3 minus 4 3/8. Once again, I'm going to remind you, I'm not going to do this every time, okay? But I'm going to remind you that 6 2/3 is the same as 6 plus 2/3. And 4 3/8 is the same as 4 plus 3/8. And we are going to be subtracting them. So I'm going to group my whole numbers together, and since what I'm doing is subtracting, I'm going to subtract this, plus I'm going to subtract my fraction piece, okay? You wouldn't say minus for everything, because that would be saying that would be the same as saying this is 6 minus 2/3, which it isn't, okay? This is a tiny bit confusing the way I'm explaining it, but I hope it makes sense. So group your whole numbers together, subtract them. Group your fractions together and subtract them. 6 minus 4 is 2. 2/3 minus 3/8. Well, let's do our multiplying. 3 times 8 is 24. 8 times 2 is 16. I'll change my colors, because those are the first two steps, okay? 3 times 3 is 9. Now we bring our whole number over, and 16 can take away 9. 16 take away 9 is 7/24. Right? That's it, okay? But notice how this has been a positive number, this has been a positive number. We haven't had to borrow anything. We haven't had anything smaller taking away from, anything bigger taking away from something smaller, so we had to borrow. But what if you need to borrow? I make it into a two-step problem, okay? So this is the last time I'm reminding you. 3 1/2 is the same as 3 plus 1/2 minus 1 6/7, which is the same as 1 plus 6/7. So I'm going to say 3 take away 1. Oopsie. Oh yeah, plus. I was right. Silly me. I thought I was wrong. Plus 1/2 take away 6/7. 3 take away 1 is 2. Now let's see what I did here. I did 2 times 7 is 14. 7 times 1 is 7. And then 2 times 6 is 12. I still carry my 2 across. And now I do this work. So I'm going to say 2, and before I didn't write the plus in because you don't really need to, but let's see what this says now. 2 plus, what's 7 take away 12? Ooh, that's going to be a negative number, huh? -5/14. Now I have a little math problem. 2 plus -5/14. This is my first step. And now, because this was a negative when I did my subtracting, now I have a second step, okay? Well, remember, you can change any whole number into a fraction by just taking away one of the whole numbers. So this is the same as 1, and anything over itself is 1. So 2 is the same as 1 and 14/14. It's really hard to write this way, and I didn't do a very good job. Let me erase that 1 so it looks a little bit better. 1 and 14/14. Do you see that that's the same as 2? That's like if you had $2 and you took one of the dollar bills and changed it for 4 quarters, you would still have $2. It would just be in a different form. Well, 1 and 14/14 is a different form, okay? So whenever you're taking a fraction piece away from a whole number, you always end up with one whole number less. So it's always going to be 1, and that makes sense here because I said this was the same as 1 and 14/14. And then the numerator is always the difference between what you're subtracting and the denominator. So let's do it this way, and then I'll show you again. So if we did 14 take away 5, we get 9. And if you think about it this way, what's 14 take away 5? 9. Okay, so if you have a problem where you have to borrow, I don't want you changing it to all improper fractions. Just subtract your whole numbers, get a common denominator, subtract your decimals, subtract your fractions, and if it turns out that you have a negative, then you just need to do one more step. And that's always going to be one whole number smaller than what you started with, and then 5 plus 9 is 14. So if you just take your numerator, subtract it from your denominator, that's your new numerator. Let's do one more of those, okay? 10 and 1/3 minus 6 and 5/8. So I'm going to say 10 minus 6 is 4. And then my problem is 1/3 minus 5/8. So I did my math already. 3 times 8 is 24. 8 times 1 is 8. 3 times 5 is 15. Okay, I brought my 4 over. I'm going to say 4 plus 8 minus 15 is -7. So I'm not finished. I still have one more piece of my problem. So remember, whenever I'm subtracting a fraction from a whole number, my answer is always one less whole number. And now, 7 plus what is 24? Well, let's see. I think it's 17. And I'm done. Okay, I know this is a different way, but try it. I think you might find it easier. That's it.